Welcome, everybody. Hope you are enjoying SQL Bits. Today, we are going to talk about when you should avoid using bidirectional filters in Power BI. Now, the session can be very short, like never. And that's the end of a session. But we want to learn a bit more about what bidirectional relationships are, why they are a problem, and the very few scenarios where it might actually sense to use bidirectional cross-filter. With that said, I'm Alberto Ferrari. I work with Marco Russo at SQL BI. We do books, we do trainings, consultings, and we are BI experts. That's enough. I'm not here to sell myself, and we don't have time to do that. Instead, we go straight to the topic. Whenever you create a relationship between two tables in Power BI, you need to understand how the filters are moving between different tables. And by default, whenever you apply a filter on the one side of a relationship, that filter is automatically propagated to the many side. So in this example, if you place a filter on product category, the filter starts from product category. Then from there, it follows one-to-many relationships. Please know that we have one-to-many relationship. And there's also this small icon that indicates the direction of the relationship. So the way the filter is going to be moved. So the filter goes from product category to subcategory, then it goes to product, and then it finally goes to sales. That's the reason why you can slice by product category, compute the sum of sales, and get a reasonable result, because the filter is moved automatically. But then the filter stops here. It doesn't go from sales to customer, I guess. Yeah, from sales to customer, because here the relationship is placed the wrong way. It's many to one. Therefore, a relationship by default doesn't go from sales to customer. That's the expected behavior, and everything works just fine as long as you use relationship this way. But if you want, you have the option of enabling bidirectional relationships, meaning that if you double-click on a relationship, you have the option of turning on bidirectional relationships. By die, the direction of a relationship can be single or both. If it is single, it's a regular one-to-many relationship. But if you choose both, then the filter context will be moved both ways between the relationship. This comes with a lot of details that you need to be worried about. First of all, performance-wise, keep in mind that moving the filter from the one side to the many side is a quick operation, and the engine is designed to do that. Whereas moving the filter from the many side to the one side is a much more expensive operation. Therefore, you will have a performance degradation whenever the filter goes from the many side to the one side. The filter is always active, and this might create some issues, but that is not the topic that I want to talk about today. What I want to talk about is ambiguity. As soon as you introduce bidirectional relationship in your model, you are at risk of creating an ambiguous model, a model where it is no longer clear how the filter between two tables needs to be moved. Let me show you an example of ambiguity still with the slide. Let's pretend that you were able to create such a model, that you cannot. But actually, you could. A few years ago, there was the option of making all the relationship bidirectional. That is when I took the screenshot, and then I stopped. If all the relationship were bidirectional, this model is super ambiguous, meaning that between any two tables, there are multiple paths. Think about a filter on sales. I place a filter on sales, and then I compute any kind of measure on top of purchases. How is the filter from sales to purchases going to be moved? Well, an option is to move the filter using product as a bridge table. So I filter the purchases that are of the same product of the product sold. And that is an option. But there's another path that goes through date. So I'm filtering the purchases that happen in the same days where the sales happen. And that's another possible answer to the filter being moved. Or I could use both filters. So if I place a filter on sales, the filter goes from product and through date, and I see only the purchases of the same product that were sold in that specific dates where the sale happened. There are at least three possible ways of moving the filter. That is an ambiguous model, and Power BI does not let you create ambiguous models, because an ambiguous model would be impossible to query. You run a query and you have no idea how the numbers are being computed. Nonetheless, it's quite easy to create models that look non-ambiguous, even though they are ambiguous. And understanding ambiguity and understanding how activating bidirectional relationships might introduce ambiguity is of paramount importance in order to avoid having problems with your calculations. I don't want to show you any more slides. Instead, I want to go directly to Power BI, so we start looking at the details. Let's take a look at the model first. This model has nothing really complex. We have sales, we have purchases, product, and date. Date is a dimension, product is a dimension, sales and purchases are two fact tables. And then we have customer that is linked to sales, and it is not linked to purchases, because of course we sell to customers and we do not purchase from customers. And all the relationships you see are unidirectional. These, and these are all regular unidirectional relationships. This model works fine, it's not ambiguous, and there are no issues. Nonetheless, it has a small drawback that we need to be aware of. In this report, I have a slicer with the customer name, a slicer with the product brand, and then I'm computing the sales sliced by brand and the sales sliced by color. You see that if I select Stephanie Adams or Alan Klein or whoever, I have a small number of brands that Alan Cherry, for example, buys. It buys only Contoso and Southridge Video, but I do not have evidence of this in the slicer. The slicer is not showing only the two brands that that guy is actually buying. It's showing all the brands. Why is that? Well, the reason is quite simple. The name is filtered in the customer table. So the filter starts from customer. The filter moves from the one to the many relationship and reaches sales. But then from sales, that filter cannot reach product because the direction of the relationship is the wrong one. Therefore, a filter on sales does not reach product, and as such, customer does not fill product. Because customer doesn't filter product, whatever I do on this slicer will have no effect on the brand. Fixing the problem and making the user happy so that filtering one slicer will filter the other slicer is quite a simple operation, because all what I need to do is to turn this relationship as a bidirectional one. By doing that, I will reach my goal because sales filters product, and at that point, a filter on customer will reach product. We can easily do that. We just double-click on the relationship, and in the cross-filter direction, we choose both. We just click on OK, and now you see that this icon shows two arrows, meaning that the filter goes from the many to the one side, but also from the one to the many side, and also from the many to the one side. And if I look at my report, now it's much cooler. I can click on whatever customer, and the numbers shown here are the numbers here are the right one, and the slicer is working the right way. Nonetheless, it's important to ask ourselves, are we working right now with a model that is correct, or did we introduce ambiguity in the model? So just try to take a look at the model and ask yourself, is it safe to use this model? Are there any possibility that between two tables there are multiple paths? If you carefully look at it, you can see that customer filters sales and then product and then purchases. That is fine. Product filters sales and filters purchases, and that again is fine. But look at date. Date filters sales, and again that is fine. But date also filters purchases, and date can reach purchases using two different paths. The first one is a direct path from date to purchases using this relationship that is a direct one. But there is a longer path that starts from date, reaches sales, then product, and finally purchases, because I activated this path. Before, that path was forbidden. There was no option of date filtering purchases. Still, having activated bidirectional, now I let the filter go this longer way. Power BI does not detect this model as ambiguous. And to me, that is a big issue, because the model is actually ambiguous. The reason why Power BI does not warn me about ambiguity is because between the path, there is one that is preferred. I mean, if you were Power BI and you had to choose between a filter that can be moved through a single direct relationship between two tables, or another path that traverses through three different relationships and has to traverse a many-to-one relationship, well, of course, you would never choose the longer path in order to move the filter. And that is exactly the reasoning that Power BI does. If there is a preferred path, then the model is not ambiguous, and it accepts the model even though it is ambiguous. Nonetheless, we do have an issue. Are we sure that ambiguity will never create us a problem? And unfortunately, the answer in this case is no. It's quite easy to create a report that shows the presence of ambiguity. Picture this. If I place a filter on date, we know, or we think, that the filter from date will reach purchase directly because that is the preferred path. But what if I place a filter on customer and on date at the same time? Now, the customer table filters purchases because customer filters sales, then sales filters product, and finally product filters purchases. So whenever customer needs to place a filter on purchases, it needs to traverse through the sales table. But what if we also have a filter on date? Then a filter on date filters at the same time purchases and sales. So given that I have a filter on customer and a filter on data, will the engine use this relationship to reduce the number of rows in sales before filtering product and then purchases? Or, because it considers this relationship as the preferred one, it will not activate this relationship at all? It's a question. We don't know the answer. We know that there are at least two possible answers. The engine uses the relationship. The engine does not use the relationship. We don't know how to answer to that. And as whenever happens when we don't know an answer, we can try. We can write code in order to understand what numbers will appear in order to figure out what is happening. That is why I created three measures. One is computing just the sum of purchases. So it's computing the sum of purchases amount or whatever column is here, producing a number. And then I created two other measures. One that disables this relationship. In this way, it forces the longer path always. It always forces the longer path. And the other measure disables this relationship so that it always forces the engine to use the shortest path. And my guess is that having three different measures, the one that uses the default chain of relationship, one that disables one chain, another one that disables the other chain, well, two of these two measures produce the same result. And at that point, I know what the engine is doing. So that's exactly what I did. And we can take a look at the report here. And this is the standard model. Here, date does not filter purchases, so I killed the direct relationship. And here, date does not filter sales, so I killed the longer path. It's not important to look at the numbers or to try to understand them. The thing is, they are all different. None of these numbers actually makes any sense. And the standard model is showing values that cannot be explained neither by deactivating one relationship nor by deactivating the other one. Which basically means that for this specific report, what is happening is that the engine is using both relationships at the same time. It's using date to filter sales, customer to filter sales, and finally moves the filter to purchases. And at the same time, it's using date to filter purchases. That, in the very special case where I place a filter on data, because if I don't place a filter on date, things are different. It will use a different path. This is what happens as soon as you have an ambiguous model. You might think about going in production with such a report, but then as soon as your customer will ask you what numbers they are seeing, it's kind of hard to answer them and tell them exactly how numbers are being computed. And besides, it is also important to know that this happens in this very special model. We are already in trouble with only 5 tables. So 5 tables are enough to be deep in trouble and no longer being able to describe how the calculations are being computed. I don't know how many tables your regular models have, but I guess 5 is on the small side. Typically, you have 10, 20, 30 tables. And if you have 30 tables, the chains of relationship become so intricate that it is very, very complex to try to understand exactly how numbers are being computed. If you have a model like this one, this is not, apart from the fact that you cannot read the numbers, but basically for privacy reasons, this is a real-world model where a customer asked me for help because the numbers were not precise. And I took a quick look at the model and then started counting the number of bidirectional relationships that were active in the model. Now, when you see this model and the numbers are wrong, what can you tell to your customers? Come on, my friend, here's my shoulder, let's try together. There's no way we can figure out how numbers are being computed. With that said, it's not all that bad. You need to pay attention to which relationship might introduce ambiguity and which relationship do not introduce ambiguity. Because whenever you are at the end of a chain of relationship, you do not have issues. For example, that relationship does not create a problem because it's at the end of a chain. Therefore, the presence of bidirectional relationship here is not an issue. And the same is true for several other relationships. You typically start from the outer part of the chain, and you start to mark all the relationships that do not create an issue because the relationship cannot be propagated further. And by looking carefully at the model, one after the other, you can start to mark as green most of the relationship, and you end up with 2 relationships which are a problem. So this is a relationship that we are not sure will not create us issues, and this is a nightmare because it's really in the middle of a very complex chain of relationships. So anything can happen here. You need to spend time, study the problem, understand it, and only when you are sure that the model works fine, then you decide whether to activate bidirectional relationships. I'm not here to tell you that bidirectional relationships are bad. You should never use them. You should never use them unless you understand the danger in which you are putting yourself by using them. Then if you need them, there's nothing wrong. Use them because they are a tool. But you need to use them knowing that you are making the model much more complex. And I want to show you, as a last example, an example where it actually makes sense to use bidirectional relationships. This is a very simple model that is modeled as a snowflake. So we do have sales, product, and then instead of having subcategory and category as attributes of product, I have a table subcategory and another table category. There's nothing fancy here, it's just a regular snowflake. And it works just fine, except for the fact that I do not have the slicer cross-filtering feature that would be useful to have. So in this example, I'm slicing by category. Remember, category has its own table. And then I'm slicing by subcategory. And again, subcategory resides in a different table. And finally, I do have product. If I go here and I filter the category, you see that the slicer on subcategory reacts as expected. So it shows the cross-filtering feature. But if I click on the subcategory, nothing happens. A click on the subcategory does not highlight the category to which the subcategory belongs. So I might be tempted to solve the problem, and actually this time is not wrong, by activating bidirectional relationship here, so that the subcategory will actually filter the category. And the question is only, can I do that? Is it dangerous to do that? Well, this time we know. The answer is no, it's fine. Because we are at the end of a chain of relationship, this is not introducing new paths inside the chain of relationship. So activating BiDi there, apart from performance issues that I still might have, activates the cross-filter feature between the 2 slicers and makes the model easier to browse. So again, it's not that you should never use bidirectional relationship. You should spend time, understand how they work, understand the consequences of bidirectional relationship, and if you really, really need them, spend enough time in order to ensure that your model did not become ambiguous because of bidirectional relationships. And I think I'm finished my time, so I just need to show you the last slide. That is, thank you. I hope you enjoyed the session. Remember, it's time for you to provide feedback. If you like the session, provide the feedback so we get better votes and we win the competition between speakers. If you don't like the session, if you didn't like the session, that's your option of ranting about the session and say, it was awful, never call back Alberto back again here. Thank you for watching. If you have any question, we cannot stay here, so just ask me outside of here because I need to leave the stage for the next speaker. Thanks.